For these examples, we want to find the domain of the rational function. Let's start with the definition of domain. The domain of a rational function is the set of all numbers except those that make the denominator 0. Okay, so basically we want to look at these rational functions and then throw out any numbers that give us 0 in the denominator. Let's take a look at the first one. Okay, we have f of x equals 4 minus 3x divided by 2. There are no numbers that we could plug in for x that would give us a 0 in the denominator of this function, since the denominator is always 2. 2 is not equal to 0, so we are good to go there. So the domain is negative infinity to infinity. There we go, also known as all real numbers. Some people write the all real numbers symbol. That works too. Like an R with a special extra bar on it. Let's look at the next one. Here we do have a variable down in the denominator. We have v of t equals negative 5t minus t squared over 3t. So what we do is we take this denominator and we say this cannot equal 0, right? Because remember, we cannot divide by 0. So then we solve for t here, so we'll divide both sides by 3. That tells us t does not equal 0. Back to our definition, the definition says the domain is every number, all real numbers, except those that make the denominator 0. So our domain here is everything except for 0. Okay, how do we write that in interval notation? Well, we want to go from negative infinity to infinity and just pluck out that single point at 0. Here's how we do it. Negative infinity, we start at negative infinity, we're moving left to right on the number line here. Then we stop at 0, right? So I'm putting in the soft bracket here. The soft parentheses means we're stopping just infinitely close to 0, but we're on the left of 0. We hop over it with the union symbol and start infinitely close to 0 on the right-hand side. Okay, so what we did there is hopped over a single mathematical point, which is really trippy if you actually spend some time thinking about what that means. But we don't have to think too much about it right now. And then we continue off on to infinity. There's our domain. Everything except for 0, that's how we write it mathematically. Let's look at this third example. h of x equals 5x minus 3 over 2x squared minus 14x plus 20. So here we're going to take this denominator and say this does not equal 0. Well, that means we have to do some factoring. Anytime you start to factor, always ask yourself first, can I factor out a GCF? In this case, we can. Right? So we're going to factor out a 2 here. How about that? X squared minus 7x plus 10, and we're still saying this does not equal 0. So remember, the denominator can't be 0. Well, now this is something we can factor fairly nicely. We have x and x. We need factors of 10 that add to negative 7. So we need two numbers that multiply to 10 but add to negative 7. How about negative 5 and negative 2? I think that'll do the trick. This does not equal 0. So we're saying does not equal 2. We're saying not equal, but we're just treating it like an equal sign mathematically. All right, we don't care about this 2. That doesn't matter at all. We'll use the zero factor property to set each one of these terms equal to 0. That gives us x equals 5, not equal 5, and x does not equal 2. Okay, how do we write it? Well, we want to pluck out these two mathematical points. Okay, so here's how we do it. We start all the way off at negative infinity. We go up the number line until we hit 2. Remember, we're moving from left to right. We stop infinitely close to 2 on the left. That's what that parentheses means. Union over the mathematical point 2, just one point. Start infinitely close to 2 on the right. We keep going up until we hit 5. Stop just left of 5 again. Union over the point 5. Start infinitely close to 5, but on the right now, and continue on to infinity. That is the domain there in interval notation.